Okay, so we're going to look at some problems from lesson 4.5 of our pre-calculus book on operations with complex numbers. And we're just going to take a few of those different examples from that lesson and go through them just so that you have a little reminder about how to do them. So first of all, let's look at some multiplication. Reminder that we're multiplying two binomials as we have here for letter A, that we just FOIL like you normally would. So we have 4 times 4 is 16, and 4 times negative 5i would be negative 20i, and 5i times 4 plus 20i, and 5i times negative 5i is negative 25i squared. So when we do the simplification, we have 16 here, and the negative 20i plus 20i, that's 0. Okay, so that's really nice. And then negative 25i squared, that's negative 25. Remember, I squared is equal to negative 1. So this is really plus 25, so we get an answer of 41 here. So the so if we multiply, and these happen to be two complex conjugates because one of them is positive and the other one is negative. So 4 plus 5i and 4 minus 5i. And for letter B here, we're going to do 3 plus I, that quantity squared, which, remember, we've talked a lot about the perfect square trinomials, but you can also think of this as just foiling it also. But you have to remember to do 3 plus I times 3 plus I, which will give us 9 plus 3i plus 3i plus I squared. So we have 9, and remember, I squared is equal to negative 1. So this would be 9 minus 1 is 8, plus 6i would be our answer for that problem. All right, so there's simple multiplication using complex numbers. And we're going to look at taking I raised to a power. And when you do I raised to a power, we want to do multiples of 4. So if I've got I to the 73rd, I want to find the multiple of 4 that's closest to 73. So when we think about multiples of 4, we got 4, 8, 12, 16, 20, and so on. And any time I have I to a multiple of 4 power, it's equal to 1. So we really want to get multiples of 4. So we could write I to the 73rd is I to the 72nd power times I. So I to the 73rd is just equal to I. But mostly we're looking for multiples of 4. And I to the second would be negative 1. I cubed is equal to negative I. So you would either have an answer of 1 if it's to the 4th power, I if it's to the 4th power plus 1, I squared if it's to the 4th power plus 2, and I cubed if to the 4th power plus 3. I'm going to look at expressing our quotient in standard form, which means that we need to get the I out of the denominator. So we have to multiply by the conjugate. So we need to multiply the numerator and the denominator by the conjugate, which means that we're going to take the I term and we're going to change the sign of it, and then we'll multiply. So we FOIL numerator, get negative 2 minus 4i plus 5i plus 10i squared. In the denominator, notice we have conjugates in the denominator, so we'll have 1 minus 4i squared in the denominator. So when I simplify this, remember this is going to become negative 10 here because I squared is negative 1. Negative 2 minus 10 is negative 12. And negative 4i plus 5i is I. And then same thing down here. This is equal to positive 4, so 1 plus 4 would be 5. So when I write my answer, I'm going to write it as in the form a plus bi, which means that I have to separate this fraction, write it as 2 separate parts. And there is expressing a rational complex number. finding the quotient of it. So basically we're dividing and putting it in standard form. All right, then we're going to look at just working with square roots of negative numbers. And when you have the square root of a negative number, we want to change it to I before we do anything else. And so letter A here, square root of negative 5 is just I square root of 5. Reminder that the square root of negative 1 is equal to I, so that just makes it square root of negative 5 would be I times square root of 5. Now let's look at letter C here. And letter C, we are going to FOIL this, but first thing we want to do is we want to change it to i's first of all. So we have 1 minus, see the square root of 16 is 4, so the square root of negative 16 would be 4i. And the square root of 36 is 6, so the square root of negative 36 would be 6i. So first we're going to change these to standard form with an I, and then we'll do the multiplication. So we get 5 plus 6i minus 20i minus 24i squared. So 5 plus 24 will give me 29, and minus 14i would be our answer for that. So there's just some basic reminders about working with complex numbers and the operations of complex numbers.